Hi, this is Mrs. Kidman, and I just wanted to give you a quick introduction on absolute value functions. So when we are starting this unit on absolute value functions, or this section, we are trying to answer this question. Basically, we want to figure out if this is the general case of an absolute value function, how does changing the letters A, H, and K, these three variables, how does that affect the absolute value function in the graph? So ultimately, we need to start here with the absolute value function. So the absolute value function has a couple of parts to it. First of all, an absolute value function is a function that contains an absolute value expression within it. All that means is that we're going to see those handy-dandy vertical lines appear somewhere in that function. In this case, the parent function, or the most basic absolute value function that we look at, is going to be f of x equals the absolute value of x. Now, what this function looks like here is, if we have our graph, this function is going to look like this. It creates a V shape here for us. And the relationship between our x and our y here is 1 to 1. So that means that I can go over 1 and up 1, and that's where this point is. If I go over 2, similarly, I have to go up 2 to get to the next point, just like it would if I were to put those values into this function. Similarly, it's going to do the same thing. If I go to -1, it'll go up 1, -2, up 2. And that there is the parent function. You can tell that this function here is V-shaped. It is symmetrical about our y-axis. Again, a quick reminder, this here is the y-axis. And there are some interesting facts about it. We will be focusing a lot on the domain and range. So remember that our domain is the possible x values. And those possible x values for this function are all real numbers. And I'll give you a tip. The domain for the absolute value functions in general is almost always all real numbers, because we're looking at a function that goes all the way from negative whatever number we want to go to. It'll go to where 0 is, and it'll keep going back, or it'll go to where that change in slope occurs. Now, that change in slope that is mentioned is called our vertex, and that's where our graph changes the direction. So right here is that change in slope, that red dot. It changes directions from going down to up. That's our vertex. So that's what our domain is. In this case, it's going to be all real numbers. Another way we can write that is with this fancy R that represents the set of all real numbers, or we can write it using set notation, that it goes from -infinity to infinity. The other component about these functions is the range. For this parent function, the range goes from 0 to infinity. Remember that our range is the possible y values that we can see. So notice on our graph here that the function in blue only at the lowest point is at y equals 0, and then it goes on forever. But it never goes below that line. So our range in this case is 0 all the way up to infinity. And those are just the possible y values that we might run into. And that's kind of our absolute value function. Now, we are looking at absolute value functions specifically in vertex form. And what vertex form means is that it's written here so that we have this H and this K, and they tell us where our vertex is. So the vertex of this absolute value function, remember, that's the point at the bottom where it changes directions or changes from a negative slope to a positive slope. Our vertex is going to be HK. So wherever that H and that K are, that's where our vertex is going to be. And that is why we want to use this. And remember that essential question. The A, the H, and the K are going to affect our function and change it from that parent function of just the absolute value of x. Now continue watching these videos and you can see how those different variables will affect our function.